Okay. Now, remember we created an infinite sequence. We created an infinite sequence of rectangles. We continued inductively. So, the relationship that we had before, namely that S sub n equals d sub n minus 1 minus S sub n minus 1 holds, and d sub n equals S sub n minus 1 minus S sub n. That we have S sub n is d sub n minus 1 minus S sub n minus 1. But d sub n minus 1 is going to be capital N sub n minus 1 delta. S sub n minus 1 is going to be capital M sub n minus 1 delta. And we factor out the delta, and we have capital N sub n minus 1 minus capital M sub n minus 1 delta. Larger natural number minus smaller natural number, that gives us capital M sub n. That's what we call it. So S sub n is capital M sub n delta. And using the same logic here, d sub n is S sub n minus 1 minus S sub n. S sub n minus 1 is capital M sub n minus 1. S sub n is capital M sub n delta, and we factor out the delta. And we have larger natural number minus smaller natural number. We'll call that capital N sub n delta. So let's see. That means that we have S sub n equals capital M sub n delta, and d sub n is capital N sub little n delta. And through this process we generate two sequences. One sequence of capital M's. These are all natural numbers, and that's key here. Capital M is greater than capital M sub 1 is greater than capital M sub 2, which is greater than capital M sub 3. And we have another sequence of natural numbers. Capital N sub 1 greater than capital N sub 2, greater than capital N sub 3. These are strictly decreasing and infinite sequences of natural numbers. Strictly decreasing. So each term after the first is strictly less than its predecessor, strictly decreasing. And these sequences are infinite, they continue. But this is impossible. We can't have infinitely many natural numbers less than n sub 1. No matter what natural number capital N sub 1 is, we can only have finitely many natural numbers less than capital N sub 1. And the same logic holds with this sequence of natural numbers also. There are only finitely many natural numbers less than M sub 1. There are only finitely many natural numbers less than capital N sub 1. This is the contradiction. This is the contradiction that we were after. So we sum it up. Since the assumption that the side and the diagonal of a square are commensurable leads to a contradiction, the assumption must be false. And therefore the side and the diagonal of a square are incommensurable. Did I say that right? Since the assumption that the side and diagonal of a square are commensurable leads to a contradiction, the assumption's false, and the side and the diagonal of a square are incommensurable.